Now I will talk about the main components of the shock absorber. The first one is the piston. The piston moving up and down within the shock absorber cylinder. It provides resistance to the fluid flow. This is really important for damping motion. The second one is a spring. Although it's not part of the shock absorber itself, but the coils will working in conjunction with it to support the weight of the vehicle and absorb little bit impact. The third one is the hydraulic flow, the flow that fall in the cylinder and enable to absorption of the shock. The last one is the damping body, the housing that contain the piston and the hydraulic flow, and it is designed to withstand high pressure. So choose the material is critical to ensure performance, durability, and safety for the shock absorber. The most business just choose steel and aluminum to the main material of the shock absorber because they both have very good strength and durability. But the main difference is the aluminum is much lighter than the steel. It will help to reduce the overall the weight of the vehicle and improve the fuel efficiency. And the corrosion, he also have very high corrosion resistance. So he didn't need actual way to improve it. And still the main advantage is the relative. It is relatively inexpensive to compare with aluminum, so they can have more cheaper price.
The tolerance of the spring affects the compressive force. The outer diameter and length tolerance of 5%, while the wire diameter of 1% is accepted. Any nicks, cracks, and scratches may lead to failure of the spring, and this is checked using ultrasonic testing. For the damper body, tolerance affects damping strength and is given as 0.01 millimeters for the diameter and roundness, and 0.1 for concentricity between both bodies. The inner diameter surface finish of between 0.1 and 0.4 microns is given to prevent wear and friction. For the piston rod, tolerance affects the quality of the system. A straightness of 0.02 millimeters per 300 millimeters and other tolerances of 0.01 millimeters is accepted. Its surface is inspected for cracks, uneven coating, and surface finish using a profilometer. For the wear band, a tolerance of 0.02 millimeters is accepted to ensure a proper seal between the piston and the damper body. The surface must be free of any tears and must retain the correct roughness. Shim stack has a tolerance of about 0.01 millimeters to ensure it has the correct damping force. The edges must be free of any burrs to prevent cracking. The spring is made from a heated steel wire, which is rolled to form its shape and is then hardened and tempered. The extensive heating of the part produces greenhouse gas emissions. For the damper body, a cylindrical tube is machined on a lathe to reduce desired shape and size. Extraction of materials using mining uses substantial electricity, producing carbon dioxide. For the piston rod, the steel is rolled, hardened, tempered, and machined and polished to produce low surface roughness. The chromium plating involves hexavalent chromium, which is highly toxic to the environment. For the wear bands, PTFE tubes are extruded and cut to the size of the washer. Raw materials used to create PTFE generate acidic and persistent pollutants. For the shim stack, they are blanked from a steel sheet, then deburred and polished to meet the low tolerances. Energy-reliant semi-automatic machining operations create high levels of greenhouse gases.